At 6:17 a.m. on December 9, 1942, a 43-year-old man in a grease-stained tan work shirt crawled out from under the nose of a bomber that had no right to exist. His name was Captain Paul Papy Gunn, and he hadn't slept in 31 hours. Above him, two men in dark trousers and scuffed work boots balanced on aluminum ladders, threading ammunition belts through a nose section that was never designed to hold them. A third crouched beneath the fuselage, both hands buried inside a tangle of wiring and gun mounts, not looking up, not speaking. The tarmac was already hot. The work was already desperate. No unit patches, no brass, no ceremony. Just four men quietly rebuilding a bomber into something the United States Army Air Forces had just officially declared impossible. The 5th Air Force was bleeding out. In the 30 days prior, high-altitude bombers had attempted to intercept Japanese convoys resupplying New Guinea 11 times. 11 times, the bombardiers had watched their payloads disappear into empty ocean. Japanese ships turning hard at the last second, moving targets laughing at textbook physics from 20,000 feet. When the bombers dropped lower to improve their aim, the deck gunners opened up and turned cockpits into coffins. The Japanese weren't just winning a supply line. They were winning the war. General George Kenney needed a solution inside of 7 days. He gave the problem to Gunn. Gunn's answer wasn't in any manual. If you couldn't hit a moving ship from above, you flew at it sideways, wavetop height, nose down, close enough to smell the salt, and you skipped your bombs across the water like a stone on a pond. Flat trajectory. A point-blank range, physics you could actually use. But to survive the approach, you had to silence the deck guns first. And to silence the deck guns, you needed something no bomber had ever carried. A wall of forward-firing firepower so overwhelming that the men behind those guns simply ceased to function. Gunn stripped .50 caliber machine guns from wrecked P-39 and P-40 fighters, aircraft so badly damaged they'd never fly again. The pilots who'd been flying them were gone too, but their guns weren't. He mounted 4 of them inside the nose of a B-25 Mitchell, right where the bombardier used to sit. Then he bolted 4 more into external cheek packs along the fuselage. Then he rotated the top turret forward. 10 guns, then 12, then 14. Combined rate of fire, 215 pounds of lead per second. Yeah, the ground crew looked at it and shook their heads. They called it Papy's folly. The Army Air Force's engineers in Ohio called it something worse. In a formal report stamped and filed while Gunn's crew was still welding, they declared the modified B-25 structurally impractical. Too nose-heavy. Center of gravity dangerously far forward. The plane, they wrote with the full confidence of men who had never flown one, would not perform properly in combat conditions. They recommended every modified airframe be grounded immediately. Gunn read the report, set it down, went back to the tarmac. If you want to see more of stories like this, please hit that like button and subscribe. It helps us share more forgotten stories from World War II. The math was simple, and it was killing them. A Japanese transport ship moving at 15 knots presented a target roughly the size of a postage stamp when viewed from 4 miles above the Coral Sea. The bombardier had approximately 8 seconds from bomb release to impact. In those 8 seconds, the ship's captain turned hard to port or starboard, and the bombs walked harmlessly across open water in a line of white splashes that meant nothing to anyone except the men who'd just wasted them. July 1942. 11 A-20 Havocs gone in 30 days. Not 11 damaged. Not 11 forced to turn back. 11 aircraft destroyed, their crews burned or drowned or simply never found. While the Japanese convoys they'd been sent to stop continued steaming toward New Guinea right on schedule. Captain Ed Larner had watched 3 of his crews go down over the Coral Sea in a single week. He described it later with the flatness of a man who had run out of ways to feel it, the flash of a wing catching fire, the slow rotation downward, the surface of the water that gave back nothing. The deck gunners on the Japanese ships were good. When the bombers dropped below 10,000 feet, trying to improve their aim, the flak found them inside of 30 seconds. When they stayed high, they missed. There was no middle altitude where the math worked. General George Kenney understood this the moment he took command of the 5th Air Force in late July. He was not a man who tolerated inherited failures quietly. He wanted solutions, not explanations. And he had already identified the one man in his command who seemed constitutionally incapable of accepting that something couldn't be done. Kenney called Gunn into his office and gave him 1 week. Gunn didn't start with blueprints. He started with wreckage. Out at the edge of the airfield, past the flight line, sat the remains of P-39 Airacobras and P-40 Warhawks that had been shot up badly enough to be written off as total losses. The Army had already stripped them for usable parts: engines, instruments, hydraulic lines. What remained were hollow frames and, in most cases, their guns. The .50 caliber M2 Browning, 64 pounds per unit, cyclic rate of around 850 rounds per minute. Gunn walked among the wrecked fighters like a man shopping at a salvage yard, which is precisely what he was. He wasn't thinking about the pilots who'd flown these aircraft. He couldn't afford to. He was thinking about center of gravity, about mounting angles, about how many of these guns he could fit inside the nose compartment of a Douglas A-20 Havoc without making the aircraft impossible to fly. The A-20 was not designed to be a gunship. Its nose housed a bombardier and 4.30 caliber machine guns. Weapons Gunn had already dismissed as useless against ship armor. He'd watched .30 caliber rounds strike Japanese steel and spark off like gravel thrown against a wall. He needed the .5s. 4 of them, mounted on a steel frame inside the nose compartment, firing straight forward. His mechanics worked through the night. They were not factory technicians following assembly specifications. And they were field men working with welders and hand tools, and the particular ingenuity that comes from having no other option. By dawn, they had the guns installed. By mid-morning, they had the ammunition feed system roughed in. By early afternoon, they stood back and looked at what they'd built. It looked, by most accounts, like it had no business flying. The test pilot climbed in without being told what to expect, which was perhaps a failure of communication on Gunn's part. He ran through his checks, taxied to the runway, and pushed the throttles forward. The A-20 accelerated normally. It rotated at the correct speed. And then, as it climbed away from the runway, it became clear that something was profoundly wrong. The nose wanted to drop. The aircraft was fighting him, pulling forward with a weight that the trim couldn't correct, in demanding constant back pressure on the stick just to maintain altitude. The center of gravity had shifted dangerously far forward. 4 guns, 200 pounds of ammunition, the math that had seemed manageable on the ground was trying to kill him in the air. He got it down. He said very little about it afterward, which told Gunn everything. Gunn spent the next 2 days lying under the aircraft, sitting in the cockpit, walking around it with a cup of coffee going cold in his hand. The problem was physics, and the solution was physics. He needed to move weight aft. Equipment was relocated toward the tail. Ballast was added. The tail trim was adjusted. The ammunition configuration was revised. He worked through the arithmetic in his head, and then tested it with his hands, and then revised it again. On the second day, a different pilot climbed in. He came back and said the plane flew like it was angry. Gunn took that as a success. The angry aircraft went to war on September 12th, 1942, and it worked so completely that it briefly seemed like a different kind of war was possible. 16 modified A-20 SS lifted off before dawn and flew toward the Japanese airfield complex at Buna, on the north coast of New Guinea. They came in at treetop height, not the cautious low altitude that still left you exposed, but genuinely low, the kind of low where you could see individual faces on the ground before they scattered. The 4 forward-firing .50 calibers in each aircraft nose opened up at ranges that bombardiers operating from 4 miles above had never been able to achieve. They destroyed 14 Japanese aircraft on the ground. They suppressed every anti-aircraft position around the airfield. They came in so fast and so low that the defenders barely had time to reach their guns before the strafers were already gone. Not one A-20 was lost. Kenny read the after-action report and wanted more. He wanted the concept scaled, standardized, and deployed before the Japanese figured out what had just happened to them and adapted. Gunn understood. But he also understood something Kenny couldn't quite see yet from his desk. The A-20 had a ceiling on what it could become. Its range was the problem. The Owen Stanley Mountains ran like a spine down the center of New Guinea, and getting a fully loaded A-20 over those mountains and to the targets that actually mattered on the other side left too little fuel for anything useful. The bomb load was too light, and the airframe had been pushed about as far as it could go. Gunn had squeezed everything out of the A-20 that physics would allow. He needed a bigger aircraft. He needed more range, more payload, more internal space. He needed something that could carry not just the concept, but its full potential. He needed the B-25 Mitchell. The Mitchell was a medium bomber, a generation larger than the A-20 in every meaningful way. Longer fuselage, twin Wright R-2600 engines with enough power to carry a real weapons load over real distances, a nose section with actual room to work in. When Gunn looked at an early B-25C and thought about what he'd learned from the A-20, he saw not an aircraft but a problem waiting to be re-engineered from the front end backward. He pulled the bombardier out, he pulled the nose guns out, and he wasn't gentle about it. There was no time for gentle. In their place, he mounted 4.50 caliber guns inside the nose compartment on a welded steel frame, firing forward. Then he looked at the fuselage on either side of the nose and saw more space going to waste. He fitted external cheek packs, blisters of metal bolted to the sides of the forward fuselage, each housing 2 more .50 caliber guns. Then he had the top turret, which normally faced rearward for defensive fire, rotated forward. 10 guns, 212 pounds of lead per second when they all fired simultaneously. He looked at it and added 2 more on each side. 14 guns, 215 pounds of lead per second, a wall of firepower 300 yards wide at the ranges he intended to fly, and which were the ranges that made every deck gunner on every Japanese transport ship a dead man before he could complete a single trigger pull. The ground crew stood around the aircraft and said nothing for a while. Then one of the mechanics, a man who'd been with Gunn since Brisbane and had seen the A-20 nearly kill its first test pilot, offered the assessment that seemed to capture what everyone was thinking. He called it Papy's Folly. The name spread across the flight line inside of an hour. It was not entirely affectionate. These were men who understood aircraft weight and balance at an instinctive level, who could feel in their hands and in the seat of their flight suits when an airframe was being asked to carry more than it was built for. 14 guns and their ammunition represented a mass concentrated almost entirely in the forward third of the aircraft. The A-20 had nearly killed a pilot with 4 guns. What would 14 do? And simultaneously, somewhere in Ohio, a team of Army Air Forces engineers was asking the same question with slide rules and stress calculations and the full authority of their credentials behind their answer. Their answer was, ground them all. The formal report landed on desks in Washington with the weight of institutional certainty behind it. The modified B-25s were too heavy. The center of gravity was dangerously displaced. The aircraft, in the engineer's professional judgment, would not perform properly in combat conditions. The modifications were impractical. The program should be terminated. The report was thorough. It was well documented. It cited the correct regulations and the appropriate engineering standards. It was also being written at roughly the same moment that Gunn's mechanics were torquing down the final gun mounts on the tarmac, and the morning sun was turning the Pacific sky the particular shade of pale gold that preceded a full day of work. Gunn did not read the report that week. He was busy rebalancing the aircraft. The problem was the same one the A-20 had presented, only larger and more stubborn. The weight forward was immense. He moved everything that could be moved toward the tail. He recalculated, he adjusted. He did the arithmetic that the engineers in Ohio had done, arrived at the same frightening numbers, and then decided that the arithmetic was not the final word on the matter. He decided the only way to know if it flew was to fly it. The test pilot who took it up reported afterward that it was the most aggressive aircraft he had ever put his hands on. It wanted to nose over. It demanded constant attention. It was not, by any standard definition of the term, pleasant to fly. But it flew. It flew angry, like its smaller predecessor, but it flew with a purpose the A-20 had only suggested. At low altitude, at the speeds Gunn intended to use it, with the guns all firing forward, it became something that had no predecessor in the history of aviation. A medium bomber repurposed as a flying artillery battery, designed to arrive at masthead height and turn the forward deck of a Japanese transport ship into a place where nothing lived. The ground crew stopped calling it Papy's Folly somewhere around the third test flight. They started calling it something else, something that would eventually spread across the Southwest Pacific Theater and appear in Japanese after-action reports with a particular note of dread attached. But that name, and what earned it, was still months away. For now, there was just the aircraft sitting on the tarmac in the Queensland heat, its nose packed with 14 guns and the exposed belts of ammunition coiling through its guts like copper rope. 4 men in work shirts and dark trousers climbing ladders and crouching beneath it and threading components into spaces they'd had to invent new ways of reaching. One man balanced at the top of a ladder, leaning into the cockpit with both hands, his face set in the particular concentration of someone who knows the margin for error is 0. Another supported the gun assembly from below, boots wide, arms fully extended, and not speaking. The tarmac reflected heat upward. Nobody looked at the camera. Nobody posed. This was not a moment for posing. Somewhere in Manila, inside the walls of Santo Tomas internment camp, Polly Gunn was keeping her children alive on whatever the guards decided to provide that week. She did not know what her husband was building. She did not know about the engineers in Ohio, or the report they'd filed, or the word impractical stamped across his life's work. She knew he was out there. She had decided that was enough to hold on to. Papy Gunn tightened the last mount, climbed down off the ladder, and looked at what 4 men with salvaged guns and borrowed time had assembled from the bones of aircraft that couldn't fly anymore. 12 of these would be enough. He was almost certain of it. The report arrived with the full weight of institutional authority behind it, which is to say it arrived like a wall. The engineers at Wright Field in Ohio had done their work carefully. They had measured the modified B-25s against existing specifications, calculated the forward weight displacement, modeled the stress loads on the airframe at low altitude and high speed, and arrived at a conclusion that their mathematics supported completely. The aircraft were dangerously nose-heavy. The modifications compromised structural integrity. The planes were too far outside their designed parameters to be considered airworthy under combat conditions. The recommendation was unambiguous. Ground every modified B-25 immediately. Halt the program. Return the aircraft to standard configuration. The report was signed. It was stamped. It was routed through the correct channels with the correct signatures at each stage. By every measure of how the United States Army Air Forces made official decisions, it represented the final word on Captain Paul Gunn's impossible gunships. Kenny read it, set it face down on his desk, and then picked up his telephone. He had learned something in the months since giving Gunn that 1-week deadline, that there existed a category of problem which official channels were specifically designed to prevent being solved, and that Gunn operated entirely outside that category by instinct and by necessity. The engineers in Ohio had never flown a strafer at masthead height into the teeth of a Japanese convoy's deck guns. They had never needed to. Their mathematics were correct in the abstract and useless in the Pacific. The Kenny did not ground the aircraft. He told Gunn to keep building them. The Japanese convoy that left Rabaul on February 28, 1943, was the largest and most critical resupply effort the enemy had yet attempted in the Southwest Pacific. 8 transport ships, 8 destroyer escorts, nearly 7,000 troops intended to reinforce the Japanese position at Lae on the New Guinea coast. Men, equipment, and ammunition sufficient to stabilize a front that had been slowly deteriorating under Allied pressure. Japanese commanders knew the convoy would be spotted. They accepted the risk because they believed, based on every engagement so far, that Allied bombers could not hit moving ships with enough reliability to stop them. The high-altitude B-17S would drop their bombs. The ships would turn. The bombs would miss. The convoy would arrive. And they were working from accurate historical data. They had simply not been introduced yet to what Gunn had built. On the morning of March 3rd, the high-altitude B-17S arrived first, as expected. They bombed from altitude. They sank 1 transport. The remaining 15 vessels turned into the wind and kept moving, and the Japanese commanders noted with professional satisfaction that the pattern was holding. Then Gunn's aircraft arrived. 12 B-25 strafers came in from the northeast at wavetop height, so low that the spray from their propeller wash left white lines on the surface of the Bismarck Sea behind them. They came in fast enough that the men on the decks of the transports had perhaps 4 seconds of warning before the guns opened up. 168 forward-firing .50 caliber machine guns. It's a wall of fire 300 yards wide. The rate of fire was so concentrated and so overwhelming that the anti-aircraft crews on the transport decks were dead before most of them could complete a single firing solution. The Japanese had been counting on those crews. They had been counting on the defensive fire that had worked against every previous Allied attack. There was no time for defensive fire. The strafers hit the transports at ranges where skip bombing worked the way physics promised it would. Bombs released at low altitude, skipping across the water in flat trajectories, striking hulls at or below the waterline where ship armor was thinnest. The Kyoku Maru took hits and began listing within 30 seconds. The Teo Maru's deck was swept clean by gunfire before a single bomb arrived. And transport after transport was either sunk outright or crippled and left dead in the water for the follow-on attacks to finish. In less than an hour, the Japanese convoy ceased to exist as a military asset. 7 of the 8 transports were sunk. 4 of the 8 destroyers were destroyed. Nearly 3,000 Japanese troops went into the water. The reinforcement of Lae, the operation that had been considered both essential and achievable, did not happen. The Battle of the Bismarck Sea was over. At Wright Field in Ohio, the engineers who had recommended grounding the modified B-25s were preparing a follow-up brief. General Henry Arnold, commanding general of the Army Air Forces, received news of the Bismarck Sea before he received the engineers. When they arrived at his office to present their findings on the impracticality of the modified B-25 program, Arnold had already read Kenny's after-action report. He had read the kill tallies. He had read the loss figures for Gunn's aircraft, which were, by the standards of Pacific air combat, extraordinarily low. He listened to the engineers for a short time, then he asked them to leave his office. Then he picked up his telephone and called Kenny and told him to send Gunn to California. North American Aviation's plant in Inglewood sat under the perpetual pale sunshine of the Los Angeles basin, a facility built for precision manufacturing at industrial scale. The kind of place that turned engineering drawings into production aircraft by the thousands. The men who worked there were professionals. They had degrees. They had processes. And they had quality control systems and specification sheets and a complete institutional confidence in the correct way to build an airplane. Gunn arrived from the Pacific wearing the look of a man who had spent the better part of 2 years sleeping badly and working constantly. His hands showed it. His face showed it. He walked into the engineering offices at North American with no particular deference to the environment and explained, with the patience of someone translating between two languages, exactly what he had built and exactly why it worked. The engineers listened with the careful attention of men who had just learned that the field modification they'd been told was impossible had destroyed an entire Japanese convoy. Gunn worked with North American's design teams through the spring and into the summer, translating everything that had been improvised on a Queensland tarmac with salvaged guns and welders into specifications that a factory could execute at scale. The cheek packs were refined. The nose gun configuration was standardized. The ammunition feed systems that his mechanics had invented by hand were re-engineered for repeatable production. The weight and balance issues that had nearly killed the first test pilots were addressed systematically, with the full resources of an industrial engineering department behind them. The result was the B-25G, then the H, then the J. Nearly 5,000 strafer variants would eventually roll out of American factories. They would serve in every theater where the United States flew combat missions. They would become the standard against which future attack aircraft were measured. The A-10 Warthog that would terrorize armored formations in a later war owed something essential to the logic Gunn had worked out under a bomber's wing in Brisbane. That overwhelming forward firepower, delivered at close range by an aircraft flying low and fast, was a different category of weapon than anything that existed before. But Gunn was not thinking about legacy. He was thinking about Manila. By early 1945, the Allied advance through the Philippines had reached the point where the liberation of Manila was a question of weeks rather than months. Gunn knew this. He also knew that Santo Tomas internment camp, where Papy and the children had been held for 3 years, was inside the city. He knew, from intelligence reports he had no official reason to be reading, that conditions inside the camp had deteriorated in ways that the dry language of military documents struggled to capture. He had taken shrapnel from Japanese flak during a mission over the Philippines the previous autumn. The wound had been serious enough to ground him, and the medical staff had been serious enough in their recommendation against flying that it had been formalized into orders. He was walking with a cane. He was, by any reasonable medical assessment, not fit for combat flight operations. He flew anyway. He did not ask for permission. He did not file the paperwork that would have resulted in that permission being denied. He found an aircraft, found a reason to be aboard it, and flew toward Manila as the city burned through its liberation with the particular violence of an occupying force that knew it was losing. The camp was liberated on February 3, 1945. American troops breached the gates in a night raid designed to move faster than the Japanese garrison could respond. The internees, some of whom had been held for more than 3 years, came out into the courtyard in the darkness. Gunn found his wife. Polly Gunn weighed 89 pounds. She had kept herself alive and kept 4 children alive through more than 1,000 days of captivity on insufficient food, in deteriorating conditions, without knowing with any certainty whether the man she was waiting for was still alive. She had done this without the option of not doing it, which is the particular courage that doesn't get named in after-action reports. Gunn stood on the ground in Manila with his cane and looked at what 3 years had cost her and said nothing that anyone recorded. There are moments that don't survive translation into language, and this was one of them. The war ended 6 months later. Gunn was eventually promoted to full colonel, a rank that acknowledged what the Army had been slow to acknowledge while it was happening, that the man improvising gunships from salvaged parts in Brisbane had been doing something that mattered more than most of what was happening in the formally authorized channels above him. He went back to the Philippines after the war. He built an airline. He flew routes across the islands he had spent years bombing the Japanese out of, in aircraft that took passengers to places that had been battlefields, and the work suited him in the way that practical work had always suited him. There was a problem. There was an aircraft. And there was a solution that either worked or didn't when you pushed the throttles forward. He died on October 11th, 1957. Not in combat, not over the Bismarck Sea, not at masthead height with guns hammering, not in the cockpit of some field-modified aircraft that the engineers had declared unfit. He died in a civilian plane crash in the mountains of the Philippines during a storm, an ordinary aviation accident, the kind that kills ordinary pilots, the final proof that the universe applies its mathematics without regard for what a man has previously survived. He was 58 years old. The B-25 strafer variants that Gunn built went on being refined and studied long after the war ended. The logic he had arrived at on a Brisbane tarmac, overwhelming forward firepower, low altitude, high speed, at close range, became foundational to how military planners thought about attack aviation. The AC-130 gunship, which would become one of the most devastatingly effective close air support platforms in American military history, traced its conceptual lineage directly to the idea that a large aircraft packed with enough forward-firing weapons and flown low enough could suppress ground defenses faster than those defenses could respond. The A-10 Warthog, built around a GAU-8 rotary cannon so large that the rest of the aircraft was essentially designed to carry it, was the direct philosophical descendant of a man who had once stripped guns from dead pilots' fighters and bolted them into a bomber's nose because the arithmetic of war demanded it. Neither aircraft carries a plaque with Gunn's name on it. History rarely works that way. The men who build the thing that makes the next thing possible tend to disappear into the gap between them. But on the morning of March 3rd, 1943, 12 aircraft that the United States Army Air Forces had officially declared impractical arrived at wavetop height over the Bismarck Sea and ended a debate that no report from Ohio was ever going to settle. The engineers had the slide rules, Papy Gunn had the guns, and the Japanese convoy that had left Rabaul 3 days earlier, carrying 7,000 men toward a war they believed they were still winning, had the very short and very final experience of learning which one of those things actually mattered when you were trying to stop a ship. The strafers came in so low the crews could see the faces on the decks. That they came in so fast that the guns were already silent and the aircraft already gone before the sound of the engines fully arrived. And one by one, in a stretch of water between New Britain and New Guinea that the maps called the Bismarck Sea, the ships went down. If you want to see more of stories like this, please hit the like button and subscribe. It helps us share more forgotten stories from World War II and comment where you're watching from.